In this short tutorial, we're going to look at the addition and subtraction rules when determining the significant figures of the result that comes from the multiple operations, whether additions or subtraction or maybe both. Okay, and we are also going to look at the rationale behind this. Okay, let's say we are making a measurement, and doesn't matter what the measurement is, what the unit is. Just let's say we are getting some number like 43. Okay, and we are doing another measurement that reads like 1.00. And then we are doing a third measurement, which we're going to have to subtract from these two. Okay, so this is going to be added, and this is going to be subtracted, and that number is going to be 2.008. What is the result going to be? Okay, now for the first measurement, this is the number. And we know that every measurement involves uncertainty. And the last digit in a given measurement or measured number is the uncertain number or uncertain digit, okay? Inexact digit. And in the second value, 1.00, this last digit is the uncertain digit. And in the third measurement, which needs to be subtracted from the total of the rest of the two, this is the uncertain digit. When we have three different uncertainties, which is going to determine the total value that comes out of these mathematical operations, okay, is going to determine the significant figure of the result. So this one is going to be the one that's going to determine the significant figure of the final result of this mathematical operation. Why? We have a better understanding and better confidence about this number because this has got more number of significant figures. At the same time, the 1000th place 8 is the estimate. And here the 100th place is the estimate. Here, the 1th place is an estimate already. So this, however accurate these numbers are, this is going to negate all that. So the final result is going to have the same uncertainty as the rough number that we have here, which is 43. Okay, let's do this math. 43 plus 1.00. If you punch the number 1.00 in the calculator, it's just going to take 1 and it's going to skip the zeros. Okay, so 43 plus 144 minus 2.008. So the result is 41.992. Again, regardless of the unit, just looking at the number, how are we going to round this off to get this? We're going to have to, this particular number has no decimal places. This has got 2 decimal places, this has got 3 decimal places, so we have to stick with this. So that means we have to have just these. We should not have any decimal point, we should not have any values beyond the decimal points. So we need to drop the whole thing, and when we drop this, the last digit that's going to be dropped here is 9, which is more than 5, so we need to add 1 to this. So this becomes 42, and that's it. No decimal point, no number, no digit after the decimal point. Okay, let's do another problem. This, we have a measurement that reads 2.016. We need to add this measurement to another measurement value that is 32.18. And we're going to have to add these two together to a third measured value that reads like 64.5. So luckily we got all the three added up, not mix of addition and subtraction. Now, looking at these three numbers, we have 64.5 with 10th place, decimal point, 1 decimal place, 32.18, 2 decimal places, 2.016, 3 decimal places. After the additions are done, the resulting value is going to have to reflect the same level of uncertainty we have in the smallest decimal place number, which is 64.5. Okay, let's do the math. 32.016 plus 32.18 plus 64.5. The result is 98.696. Again, this is much more accurate than the smallest decimal place number in the problem. But we cannot have that because we cannot get a more certain number from a less certain number to begin with, okay? So this has got one decimal place. We need to keep this decimal place and drop the rest of it. And when you do that, because the last digit dropped is more than 5, we need to add 1 unit to this, and this number becomes 98.7, and then drop the rest of it.